not very. So basically, we consider very simple systems. Sorry, here is going to be scanned my note. The system is the single degree of freedom and K, C, and M. And this one is under, let me rewrite here. How about that? Okay, those are our parameters here. So basically here we want to calculate those the forces like listed here. The first one we want to determine omega n natural frequencies and then zeta, etc. Why? Because we want to get ourselves ready for our goal is really to determine the steady state response. So the steady state response, basically here we want to determine is capital X. We want to determine this value, and from here basically we know that we know the capital X divided by delta st, and that is our formula here. 1 minus r squared plus 2 zeta r squared. Okay, we have this formula. So basically the magnitude simply is delta st and multiply with the multiplication factors here. Okay. So from here, basically here we see how much information we need. We know R equal to omega divided by omega n. So we can deal with when omega equal to 132. Okay, so the first case when omega equal to 132 and radian per second. So that means we have omega, and we don't know the omega n. So we need to calculate omega n. So that reason why the first question is we get ourselves ready for omega n. That's the reason here, because we have to use the omega n here. Okay, so we're using the omega n, we determine, and now that is a k divided by m. And we plug in the k value and the m value here, and pay attention to the unit conversions. And basically that one will be equal to A57.8 divided by 0.0492. Okay, again we put the unit conversions, and this one will be equal to 132 radian per second. Okay, and now in these formulas we also need the damping ratio. So the second question is get ourselves ready for the damping ratio. So damping ratio, given those ones, how can we convert the damping ratio? I think maybe we can try is this. We know the system is be written by this. And also we can convert it into Q zeta C over M x plus K over M x equal to F divided by M. Okay, and we pay attention to that term because that is a standard form for us to determine compared to Q zeta omega n x dot plus omega n squared x. Okay, so this one is the same. So compared to the two forms, we know that from here to zeta omega n equal to C over M. And so from here we know that in this way zeta will be equal to C over M divided by 2 omega n. and good enough, we are given C and M, and we just calculated omega n. So we plug in everything here, the data will be equal to 0.0085 here. And again, data is the damping ratio. There's a no unit. Okay. So we have everything ready, so we can proceed to determine this one. So therefore, from here we know the data. So for this case, for the search province, we have our natural given the working frequency and our natural frequency equal to the same value. So that's equal to 1. So therefore, the capital X will be equal to plugging. Another one, I forgot, what is delta ST? Delta ST is our static diffraction. How do we define the static diffraction? Do you remember?
Force.
Force? What kind of force? The apply. So that is this one, right? And I think here I need to give the unit Newton. Okay, so taking that one, the magnitude of the given force and divided by the spring constant. Right, okay, so this one, delta ST, will be equal to, whoops, I didn't calculate it. Can I leave that to you? Okay, so in this way, the capital X for this one, we plug in everything, we all have all the numbers, so that is this one. Okay, and for the fourth one, we have R equal to, right now the omega, for the fourth one is 125 and divided by 132. So we have this number ready, and that is 0.947. So again, we can just very quick to plug in here, and then we can determine that is 0.005. You good? Okay, so that is the two very quick exercise. And when we add a resonance, we have that value. When we have a little bit smaller, then the value is a little bit larger than the smaller one. Sorry, this is a large one, this smaller one. Good. The part of the homework, this time the homework, I think, 5. Yes, 5. The homework 5 due at the end of day of Sunday. So part of the problem is very straightforward. Simply take everyone to go to the fundamental, the exercise to get familiar with these kind of equations. Okay. And the next one